All right, then let's look at how we're going to add vectors. So we went over our strategy for adding vectors last week, and now let's try to put that in place. So what we're going to do is we're going to go backpacking, and so we're going to start in the parking lot, and we're going to go 4.5 miles, 25 degrees south of east. Then from there, it says we walk 5.5 more miles at 40 degrees north of east, and you camp for the night. The next day you wake up and hike 6.1 more miles at 20 degrees north of west. So at least here they're nice and they tell us we should draw a picture. So we'll start with that. And so we draw some origin axis where we're going to start. And it says we go 4.5 miles south of east. So this is east, and we're going to go 4.5 miles south of east at 25 degrees. So here's 25 degrees. And this we'll call vector A. And so vector A is 4.5 miles at 25 degrees south of east. All right, so we have our first vector drawn in. The next one, it says, from that point, you walk 5.5 miles. We draw our little thing, 5.5 miles north of east at 40 degrees. So here's east. We're going to go north of east. I don't know, like 5.5 miles. So this is vector B. Here's our 40 degrees. So vector B is 5.5 miles at 40 degrees north of east. Oh, it's a terrible B. Okay. Now, the last one it says is we go 6.1 more miles at north of west. So we draw our little origin. This is west. We're going to go north of it. And it says about 20 degrees, and we go, this is vector C. So vector C is 6.1 miles at 20 degrees. Oh, not north. It's north of west. There we go. North of west. And here's our 20 degrees. So we said that we're going to draw a picture just to have a reference. We know that this will represent R, where R is A plus B plus C. And they ask us for the displacement and the total distance height. All right. And so here's the vector, that's theta for R. Theta of R. Is everyone good with that? Now, to do our components, what we have to do is we have to do here's our vectors. We have vector A, B, C. And then we're going to have our X part and our Y part. Actually, I might stretch this over just a hair. So the X part here, we know that it's going to be 4.5. Now, when we're looking, what I recommend is there's two ways you can do this. The easiest way is to look at your picture and assign the plus or minus. So in this case, it's 4.5 miles cosine of 25. But we notice that it's pointing in the positive direction for the X. So we're fine. Here, again, this is 5.5 miles cosine of 40. And this one also points in the positive X direction. Now, vector C is 6.1 miles cosine of 20, but we put a negative here because it points to the left. Remember, these are vectors, so they point right, left, up, and down. So these would be our three vectors. So then we could come in and calculate what's 4.5 cosine of 25. We need to calculate these numbers. .08. What's 5.5 cosine of 40? 4.21. And then 6.1 cosine of 20. Negative 5.7. Now we can repeat the same thing for the y part, where we say, the y's, this one is 4.25, right, and that's sine of 25. Now notice this one points down. So if we're looking at our components, this was the x, here is the y. This is the x, here is the y. This is the y, here is, well, wrong side. We'll do this. Be consistent. Here is the x, there is the y, right? Those are our x's and y's. So we see that this one, for vector A, the y is negative. It points down. Now for vector B, we have 5.5 sine of 40. And then this one is 6.1 sine of 20. So then we get our y part. And these two point up, so they're positive. So let's get our y parts. Yeah. Because for vector, oh, it's 4.5. I'm sorry. I miswrote that. Thank you. Probably that was supposed to be a 5, and then maybe thought it was a 2. My handwriting. All right. Negative 1.9. Okay. 0.54. 2.05. Thank you. 0.9. 0.9. All right. So now to get R, what we want to do is we're going to have R. So Rx here, we're just going to add these three numbers up to get our Rx. Right? And so when we add those three numbers up, what do we get? Because we remember that Rx is Ax plus Bx plus Cx. It's the addition of the three x pieces. And then Ry, while you're punching into your calculators, is Ay plus By plus Dy. So what do we get for Rx? This is 2.56. And what do we get for Ry? 3.73. So what we see is that our R vector is 2.56 this way and 3.73 this way. And this represents our Rx, and that's our Ry. Right? We have these two. So this vector here is this plus this, and it makes that blue triangle. So here's our Rx, and there's our Ry. Is everyone good with that? So then to get R itself, we remember that R itself is the square root of our 2.56 squared plus 3.73 squared, because we built a new triangle out of R. And what did we get for this? 4.5. And then if we need our theta for the angle, it's the inverse tangent of 3.73 divided by 2.56. That should be greater than 45, so 52. 55.5. 55.5. Okay. Now, if that was for the displacement, if they also asked us for what's the distance. So how will we get the distance? What was our definition of distance? Distance is the path taken. So you would just add up these three numbers. So the distance is 4.5 plus 5.5 plus 6.1. So that's 10, 16.1. Is everyone good with that? So displacement is a vector, distance is just. Because if you told me you hiked 16, if you said, oh, I said, oh no, you only hiked 4 miles, you'd be like, no, my legs told me I just hiked 16, right? So there'd be a difference. Is everyone good with the strategy? How we can make a sketch, break it into X's and Y's, add them up, come up with the displacement. Right? All right. Then let's try that one more time. So, but now let's put in some different terms, okay? And look at this a little bit differently, just to have some practice with some different terms. So just so we can always think about vectors.